Now, after we know the features of the basic tangent or cotangent functions, and we know the tangent function has a period of pi, it is increasing over each interval from, for example, negative half of pi to pi. And then, yeah, with vertical asymptotes, etc. So, and the cotangent function is decreasing over the interval from 0 to pi open. That means not including 0 pi, they have also vertical asymptotes. So we just remember one period, for example, on this interval, the cotangent function that is decreasing, and then you can extend, right? So let's look at some variations of tangent functions. Assuming we have a tangent function that is in this form, with certain a, number a times tangent of bx minus c. Here, a, b, c are numbers. So how do we graph it? The general strategy is we can simply consider this as a quantity. Let's call it t. And immediately this, like by changing of a name, right? To look at the whole thing as a t, then immediately the function becomes a very basic tangent function, tangent t. At the most, you can still include the a number. So at least this is very simple looking. So that's our strategy. We just treat this quantity as a certain, just one variable. And that variable, when it's negative half of pi, we know the tangent is undefined. When it is positive half of pi, the tangent is undefined. Then we can figure out what is the x. Yeah, from there we can solve for x. Then we will see the vertical asymptotes. Because we know vertical asymptotes for the basic tangent function, right? When x is negative half of pi or positive half of pi, they're undefined. And also, if you continue to minus a pi, for example, and if you continue to add another pi, then we know that's another vertical asymptotes as well. So we have infinite number of vertical asymptotes for the tangent function. But the very important thing is we want to draw one period of the periodic function. So let's also set it to negative pi over 4 and set this quantity to be positive pi over 4. At least we know tangent value is either negative 1 or 1. So that will make it simple. Let's actually look at a specific problem. Here in this function, you see this number, there's a number 3 and number 2. So in this, and we want to sketch such a variation of tangent function. So to sketch it, we treat this quantity, whatever that is, let's call that variable t, for example. And we know when this quantity, let's say t, it's basically we try to figure out that this tangent t, right? This part, tangent of t, is just the basic tangent function. And we know we have vertical asymptotes when t is negative half of pi, when t is positive half of pi. So when t is negative half of pi, that means 3x is negative half of pi. Then what is x? X is, we divide 3 both sides, so pi over 6, negative pi over 6. For this one, we divide 3, so pi over x positive pi over 6. So that means we figured out already vertical asymptotes for this function. So that means our one period should be contained between the negative pi over 6 and positive pi over 6. So let's see. We also need some special points. So the special points is, so first of all, we know our picture. We want to find, here is a negative pi over 6 where the function is undefined. At positive pi over 6, function is undefined. So those are the vertical asymptotes. So we want to find 3 points. So let's just let this t value be, so let t be 0, negative pi over 4, positive pi over 4. Remember, the tangent of t will be at negative pi over 4, it will be negative 1. At 0, the tangent will be 0. At positive pi over 4, it is positive 1. So we get 3 ordered pairs. And also, if you have twice of this, so we can multiply it by 2, right? 2, then this will be negative 2, 0, positive 2. So that means at this negative pi over 4, we have this function value. Certainly, this is the y value. Yeah, so we have already created a table that is y versus t. However, we don't want to have y versus t. We want to have y versus x. So let's convert t, because t is actually 3x. Don't forget. So the t is actually same as 3x. So we can easily get x from here. So that's the table. Because the y versus t is really easy, so we make things easy for us. But now we have to go a little bit further. Let's see, when 3x is this, what is x? So we can figure out that x must be 1/3 of this, right? So 1/3, 3 times, so 12th, 0. So 1/3 of pi over 4, which is pi over 12. So then we immediately get the relationship x versus y. That's the point we are looking for. So each x has a y value, right? Each x has a y value. And then we have 3 key points to graph. So let's actually indicate where is the negative pi over 12. This is a positive pi over 12. That's right between this. And then this tangent function will give negative 2 and 0 and positive 2. So then we can do a sketch. So some increasing curve passing through the origin, go through all 3 points. Then you get the sketch passing through the points. That's one period, because we know the tangent function will be increasing. And then you can extend to more than one period. So that's the process. Yeah. So to remember, the trick is to make it a basic function, but view this whole thing as a t and view the tangent of t, right? Just the basic function. Then we know the 3 key points. And then we can find the y as twice of that tangent value. So instead of -1, 0, +1, then we get twice of the function value. And then eventually we get x versus y. So we get the points. So that's the idea. But you see, we can connect for each ordered pair, we get a point. Then 3 ordered pairs, we get 3 points. And one period of this tangent function is done. Also, you notice the asymptote right at here. And 3 key points. So you see this, which is a -π/12. So I think yeah, so the negative, so just point out one thing, that is -π/6, 0, +π/6, and -π/12 is right in the middle between these two, right? Yeah, +π/12 is also right in the middle of these 2 points. So that's the one in the middle. So you know the key points, they are nicely spaced out. And then the x coordinates. And then the y values, just simply simple values to calculate. So if you graph another tangent function like this one, let's just apply our technique. Think this as a t, for example. We know when t is a negative half of pi or positive half of pi, we have asymptotes, right? That's for tangent t. That's the basic function we know. When this is a t, then immediately we get a basic tangent function. For that basic function, we know when when this t is negative half of pi or positive half of pi, undefined. So, and then what we can do is to first sketch to find the vertical asymptotes, because from here, what is x? When this quantity is negative half of pi, the given function is undefined. That means when x is equal to a certain value, this tangent is undefined. So we have to figure out that x value. Just to solve this equation for x. How do we solve? First, we add pi both sides. You add pi, you see, add pi to both sides of the equation. And what we get is 2x equals positive half of pi. And then we divide 2. We will get x equals pi/4. So we divide 2, then we can immediately get the x. So from here, we get x equals pi/4. From this one, we can solve similarly. So this one means x equals pi/4. And this one, you add pi to both sides. That will become, after you add pi plus, so that will be 3 pi/2. Right? Then divide to both sides. Then we get x equals 3 pi over 4. So this and this, we know those two vertical lines are vertical asymptotes. So x is pi over 4, this one, and x equals 3 pi over 4. Let's show that. So what you see, x is a pi over 4. This is 3 pi over 4. This is a pi over 4. And we can make sure that these are the vertical asymptotes for one period. So definitely graph will not cross this because there's no function value at this at this x. So whenever x is this one, pi over 4 or 3 pi over 4. So then what is in the middle? In the middle point, that is when between pi over 4, you see between pi over 4 and 3 pi over 4, we have these two, between the two, there is the there is one point where y will be 0, the function value will be 0. That's right between, in the middle of the middle point of this interval. And also here this value and that value, right? So this is another middle point. So this is the middle point on the left half. And that is, there's another middle point on the right half of the interval, because this is the total interval we're looking at. Yeah, total interval. So there's left half and right half there. So you just kind of divide into 4 portions. Then you can see on this point, then there's a key point, another key point based on our discussion. So this to finish one period. Of course, the giving a table is very convenient because that way you can get more clear picture. So that is for this quantity, we pick the 3 key points. That's our t, right? When we view that as one single variable, when this variable called t is this value, that value, and this value, then the function tangent at this t will be -1, 0, +1. So with that, then we can figure out the corresponding x. Because for example, when your t is this, what is x? We just need to solve each equation. Let's solve one at least to see how, right? So when this quantity t is -pi/4, that implies x has to be, okay, we add pi both sides. So that's a 3 pi/4 when I add pi to both sides. Then x will be 3 pi/8. So that's how I get x. So we can figure out the corresponding x when this 2x minus pi is 0, what is x, right? When 2x minus pi is pi/4, what is x? So once we get, the purpose is to get x versus y, not the t versus y. Although the t versus y is very simple, right? You see, we know the 3 key points. The tangent of t is a very basic function. But eventually, we still need the x, y as ordered pair to plot the graph. So we can get the precise coordinates right? The x, y coordinates, the x and y coordinates. Yeah. So then we can get a total of 3 ordered pairs. Then we can show the 3 key points. And you get 1 period using the 3 key points. But after you draw more tangent function, you realize the 3 key points are really equally dividing the 1 period interval. That's what I commented earlier. So that is, you see, this is 1 period, pi over 4. So you see this 1 period, yeah, separate. Then we can see this is right in the middle. That's right in the middle. That is negative 3 pi over 8. This is a positive 3 pi over 8. That's a 0. I mean, that is a pi over 2. Right in the middle of this overall interval where the 1 period is defined. Yeah, you see. So basically, you equally divide into 4 portions, and then you figure out where is this, where is this. So this, yeah. Um, we can go back to see once more if we put more points, you can see that if I include the asymptote location at x equals negative pi over 4, right? 3 pi over 4. And those are the x values where the tangent is undefined. But we can still just see that means this pi over 2 is the middle point. Yeah, it is the middle point. And this 3 pi over 8 is the middle point of these two. And 5 pi over 8 is the middle point of these two. Yeah, so you can see the overall interval is just yeah, so equally divided. Yeah, so that's to see how the structure is. Okay, so what about cotangent? Really very similar. So if you can do the tangent, I believe you can do cotangent. In the similar form, all you need is to still the procedure is to find asymptotes. Let's try one example. Let's suppose we want to graph cotangent function. That's cotangent 2x. Yeah, just graph the function. So 2x. In order to graph cotangent 2x, and consider our technique. Remember the 2x, we treat it as t, and we know this cotangent at t is undefined at where? Let's consider only one period. That is when t is 0, right, or pi. Whenever you increase by pi, so 2 pi, 3 pi, or negative pi if you minus pi. negative 2 pi, negative 3 pi. So at all those are undefined. But let's just look at one period. Suppose 0 and pi. So if 0 and pi are the vertical asymptotes for 2x, when 2x is 0, undefined, right, for cotangent. When 2x is pi, undefined for the cotangent. That means when x is half of 0, which is still 0, that function is undefined. That means when x is half of pi, undefined. So we already know the vertical asymptotes, which are the two vertical lines, x being 0 or x being half of pi. So let's take a look at the picture. So you see, at 0, at half of pi, we know we can sketch one period. So, and of course, there are next period, right? Another period. So, but all we can do first is to get one period. So for this one period, we know the vertical asymptotes. And then immediately with those, we can know what's the middle point between 0 and half of pi, that's pi over 4, that's the middle point. Yeah, at this middle point, the cotangent is 0, right? And then we can decide what's for this interval on the left half and the right half, and we can get the midpoint of the left half, which is pi over 8, because 0 and pi over 4, you see there is a midpoint, which is pi over 8. On the right half, you see pi over 4 and pi over 2. These two, there is also a midpoint, which is the 3 pi over 8. So once we get these two, we know at left midpoint, we will get 1. And decrease at the right point, we will get the negative 1 for the tangent function. So we get 3 key points. Using this rule of partition, we get 3 key points, just like how we get the 3 key points for tangent function. So no, but we get a decreasing curve, right, over this one period, and then extend it. But you see, it's not always decreasing, because on each subinterval, you see a continuous decreasing curve. But if we choose this interval, for example, if I choose this interval, it's not decreasing, because see, the larger the input value x, right? Suppose I pick a larger input value, or let's include a little more. Yeah, just on this interval, it's decreasing, because the larger the input value, the smaller the function value. But over here, it's not true, because this one is larger, but has a larger function value compared to certain. So it's not always decreasing, right? So the function value can become larger. It's not always decreasing. It's strictly decreasing if we restrict our attention to a certain interval, that, yeah, continuous curve, where we have a continuous curve of cotangent.